Okay guys, listen up. This is the lesson since I'm out on the ropes course today. I'm going to go over how exactly to teach this and how this is going to be rolling today. So today you're working at page 4 and 5 of your packet. So that's going to be, you've already done this and you've already done this. Miss Underwood will check it off for you if it's done. Alright, so now we're on to page 4, which is developing ideas, and page 5, which is the decision-making matrix. This is from the lesson we did last week. Alright, so it should be the same thing. Alright, so we're going to go over that in just a second here. I'm going to just give you an example of my 4 that I came up with right now. I went ahead and I designed my 3 rockets, and here's what they look like, okay? I have one with 3 fins, I have one with 4 fins, and I have one that I call the circular design, okay? So those are going to be my 3 that I'm going to come up and do in the decision-making matrix here. Let me show you how the decision matrix works, okay? So I'm going to come back over to here, and I'm going to type my 3 in. So it's a 3 fin. There's the 4 fin. And then there's circles. Okay? Next, what I'm going to do is I'm going to come up with some criteria of what I think a good design is. Okay? Some criteria of a good design is, some criteria of a good design might be that it's balanced. A good rocket is balanced. Okay? It might be easy to build. That's always a really important one when we're in the limited time, is easy to build. Easy to build is very important. Okay? Another one might be recovery system. I'm going to talk more about recovery systems later on. And then another one might be lightweight, because that might go the highest, right? You're going to come up with 2 additional ones on your own. All right? So what you're going to do is you're going to rank them, okay? And you're going to rank them on 1 being the best. Or wait, the worst. Sorry, the worst. And 3 being the best. Obviously, 2 will fall somewhere in the middle, okay? So we're going to go ahead here. So balance. My best balance one, I'm going to guess to be, I'd probably say the 4 fin one, okay? And probably since it's got 3 fins, I'm assuming that's going to be the least balanced one. Circles, that'll kind of be in the middle, okay? Now, easy to build, 3 fins, that's 1 less fin. That'll definitely be the easiest to build. Well, 4 fin, that's going to take forever to build. And the circles, that'll somewhere in the middle, okay? Now, my recovery system, I have the same parachute recovery system for all of them. So I'm just going to give them all 2s, okay? That really isn't a good criteria to judge off of, but for now, it's okay. Now, lightweight design is also important, and I think that the lightest weight is going to be my 3 fin rocket, okay? And my heaviest one, therefore, would be my 4 fin. And again, circle somewhere in the middle. So, you're going to come up with these 2 additional ones. You have to come up with 2 additional ones. I am just showing the example of 4. I give you 4 criteria you can use later on. So then you go through and you add them up. 3 plus 3 is 6, plus 2 is 8, plus 1 is 9. So the total of this one will be 9 right here. Oops, 9. Okay? 3 plus 2 is 5, plus 1 is 6, plus 1 is 7. So my 4 fin rocket only got 7 points. And 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. Okay, so circle's got 8. So based on this, I'm going to build my 3 fin rocket. And why am I going to build my 3 fin rocket? Because it got the highest score. It scored the highest on the decision-making matrix. DMM I call it for short, okay? Now, once you're done with both those pages, you are done for the day. If you do not finish those pages, you have homework. So, remember that it is very important because the Monday we come back from break. Monday being, I believe, the 2nd of May. So 5-2. All pages 1 through 5 must be done. If you are not done, you are not able to go on and start building, okay? So once again, you might want to write that down in your agenda books that you have homework if you don't finish this in class. You should finish this in class. Now, before I let you go and you have a work period with Miss Underwood today, I'm going to go over some aspects of a good rocket design. Now, I have some here, okay? Before I do that, or let's come back here. So, if I was to zoom in on my picture here, let's just talk about this top picture right here. All of your pictures must have a top view and a side view. Also, you should show the angles and the dimensions. Now, these are scale dimensions. They're not the actual dimensions. So, for example, this is not actually a foot drawing, but it is going to be a foot-long rocket, okay? These notes in the drawing, these are annotations. And I'm going to show you all the annotations that are required here in my second image I'm going to show you, which I will show you all aspects of a good rocket design. Okay? Let's zoom in on this. Oh, that's a little too far. Okay. So first of all rockets have a nose cone. You need to annotate your nose cone. All rockets have a fuselage. You'll need to annotate your fuselage. A guide tube, you need to annotate your guide tube or show where it is in your drawing. Ours is going to be used as straw. An engine mount, okay? What we're going to use in this class is a paper clip. And fins, which is cardboard, okay? So you need to show all these on your rocket design. Notice, my fins are drawn, okay, on the bottom. It's important that they're on the bottom. Also, your nose cone is going to be removable. We'll talk about that later. Up here on the top here, I have some. Does everybody recognize this symbol? This symbol is the less than or equal to symbol. That being said, your variables, which is fin, need to be greater than, excuse me, I misspoke there, greater than or equal to 3. Okay, so you need to have more than 3 fins. Or you can have 3 fins. Also, balance is key with this rocket. If you only have 2 fins, your rocket will not fly. It will go up in the air and it will crash land. We don't want that because you'll get a bad grade. You need to have an angle that is 120 or 90. Notice that my 3 fins, they're balanced. They're all equally distributed. My 4 fins, they're all equally distributed at 90. In 5, if I had 5 fins, they would equally distribute at whatever they are. I believe it's something along the lines of 60 degrees. Alright? Also, let me talk quickly about fins. Okay? Most of them, if I was on a side view of my rocket, they would be perpendicular, which means they come to a 90-degree angle. Alright? But if you're really high quality, you can make it angled like this. What will happen is it'll spin in the air. But if it's done improperly, you're just going to crash land. So the easiest one is to make all your angles perpendicular, or they come to 90 degrees. Okay? Last but not least, let's talk about some recovery systems. One recovery system is a streamer. Okay? Simply, it's going to be a line with it with a streamer tied to it. That'll slow the rocket down as it crash lands. A better but more complex is a parachute, where it pops out and it equally is distributed and it slowly slows the rocket down to the ground. Both of them are fine recovery systems. If you're feeling a little adventurous, you can use the complex parachute system. But if you're feeling like, I don't know if I can handle that, or you're running out of time, we can always go back to the streamer, okay? But once again, those are just simple recovery systems. If you have any questions, please let me know next class. Once again, on the packet, pages 5 and 4 are needed to be done today. Page number 3 should already be done, and page number 2 should already be done as well. Okay? If this is not done yet, you can spend any additional class time today doing that. If you have any questions, please see Miss Underwood. She will help you.